Everybody, welcome to our computer science lecture for today. Yesterday, we started with a series of lectures where we're going to go through a past paper, for example, a past paper that was one of the past exams. And we discussed one of the first things was to first try and understand the problem. We made a few notes on the paper itself, and then we went through the design phase. And today we're going to continue, and the objective of today is to what I like to call creating our framework for our program. Now, the framework is just creating the files, creating the libraries, the header files, linking them all together, and that's the objective of today. And I'm going to demonstrate this using the VPL system. So it's also going to be fairly new to me because I haven't done much on the VPL itself. It is Prof. Coulter's, let's call it his brainchild, and I think it's a really good system. So we're going to try and do most of this prac on the VPL system. So bear with us as we go through it. As I said, the objective of today is to get the various libraries defined and declared, the various files for that, getting the header files created, etc. And then that's the only thing that we're going to try and establish today. Okay, so let's, without further ado, share my computer screen. Okay, let's wait for it. I just want to, as soon as it's shared, I'm going to remind everybody that this is the paper that we're working through. It is the 2020 exam paper. Now, some may ask, but how does the semester test look like? It's exactly the same. Okay, so semester test and exams, or semester test 2s and exams for Computer Science 1 are exactly the same. We're busy with this SRI epidemic modeling system, and we've made a few notes. We're going to come back to this paper at a later stage. As I said, next phases, we're going to just get our project up and running. We're going to create our various files that we need, and that's going to be one of the major objectives that we're going to try and accomplish today. Secondary objective, if we get there, is to try and populate some of the components already in the header file that we might need. Okay, so this has got something to do with SRI, which is susceptible, recovered, infected, and something to do about modeling. So I'm going to try and create my file names also in this theme. Now let's go ahead and get to our VPL system. So here's our VPL system. And you'll see that Prof. Coulter has kindly created this VPL practical test preparation area for us, where we can go ahead and create a bunch of stuff without an evaluation occurring whenever we try and run something. So it's honestly just like a scratch pad where we can program, we can delete, we can program some more, and we can use this for basically practicing. So I'm going to go in there and I'm going to start practicing. Obviously, my screen will look a little bit different than yours because I have a lecturer version of the screen. Okay, so the first file that we always need to create is main.cpp. And okay, there we go. I'm going to just maximize this so we've got a nice view here. Okay, so there's main.cpp. I'm also at this stage going to create all my other files that I'm going to need. So let's see how this can be done. So we'll save that. Well, let's have a look. I think it's plus file list. Is this the option? New, there we go. What other new file do I want to create? So let's say lib, and I think let's call it libmodel.h, and I'm going to use the same type of file name for my implementation file. So there's libmodel.h, let's just save that. Let's create another one here. Let's close that. Let's call it libmodel.cpp. Okay, so these are the three files that I'm going to require. Let's take each file on its own. So let's go to main.cpp. Let's create our basic information that we typically need in main.cpp. Now, normally we've got this hashtag include iostream defined in here. We've got using namespace, namespace standard. And then we start with our main function. And normally we've got to return 0. Okay, so that creates a very, very basic main.cpp, and we can already run it, and we shouldn't actually see anything. You see it's empty. Connection is now closed already. Nothing appeared, obviously, because nothing was given. All right, so that's our basic main CPP. We'll add to this file in just a minute. Let's continue with our header file. This is one that's a little bit more important. And you'll see that because we're not using code blocks, we have to create our guard conditions ourselves. So the guard conditions always start with this preprocessor definitions that says if not defined. Let's say lib model underscore h, because that describes this file that we are. Then what we're going to do is we will then define it, lib model underscore h, and at the end of the file we will have the guard condition closing, which is endif. Okay, those are the basic guard conditions that we need. Yeah, so let's keep that there. And then already I'm going to start setting up my namespace at this point in time. So namespace, let's just confirm what was the namespace that we needed. We needed the SRI space namespace. So let's go back there. SRI space namespace. Right, so that's our namespace declared. We're going to need that, and we're going to put this in our implementation file. But because we've created our header file, we have to now link this header file into both our implementation file and the main file itself. So let's go and do that. So let's say hashtag include libmodel.h, and let's go and include that in our main as well. And in our main, we're going to use our namespace, using namespace. What did I say? SRI space. And let's declare, yeah, we've already got namespace declared here as well. Okay, so let's save everything and let's see if we can build. Right, hopefully no errors. Okay, that looks correct. No errors at this point in time. I just want to quickly see what happens if I do make a mistake I've actually never seen. What might happen? I don't know. I don't know how it actually shows if there's errors in the code. Well, okay, obviously there's no test cases. That makes sense. Let's have a look here. Obviously nothing there. Yeah, I'm not sure. Okay. Hashtag include libmodel.h. Right. Where we were lost. Okay. Let's just quickly go back and see if there's any comments or questions. I have muted the comments and questions for me today because I found it extremely distracting and I don't get to what I want to talk to. So I'm going to pause now and again, go back to the comments and questions, see if I can talk about it, and then we will continue. So let's go back. There's already 12 here. Am I the only one hearing screeching sound? I'm not sure. Can we code in C++ and copy and paste to the VPL? Well, I am coding in C++, but I assume you're talking about code blocks. Yes, you may. Okay, reload. I reckon so. Reloading help. Thanks, guys. So does this course have exam exemption like Informatics 1A? You do very well in semester test 2. This was discussed yesterday. So Mr. or Mrs. Mashamaite, please have a look at yesterday's lecture. Is it considered as cheating if you just copy and paste it from code blocks? Absolutely not, Mr. or Mrs. Lebaka. Sure, how follow along with you in VPL. How did you create a .h and lib.cpp file? Okay, I'll demonstrate that again just now. Just watch the recording, okay, but I will demonstrate it again. I can just remove the file again. It's okay, I figured it out. Okay, mooi. But the lecture vids will make you understand it more. Okay, can we write the code in code blocks? I've already answered that. Can we save? Does it save all the files? It actually saved all the files. Okay, but I've mentioned, we covered all the questions. All right, now let's get back to the next steps. So we've got this basic structure now set up. Now what I normally like to do is I like to take the header file and actually start expanding this. Now one of the first things that you will notice when you start using the header file and you're going to start creating functions in the header file is you may end up with weird errors such as string is not declared or weird things like that. And that is purely because we haven't included all the libraries that we need and we haven't defined whether we're going to use the standard namespace as well. So one of my first steps that I normally do when I approach a project like this, I include all the various, let's call it the standard libraries that through experience, because I've been practicing these semester tests and these types of questions and things a while now, I already know the libraries that I'm going to require. Now, let's just again confirm what is a library. A library stores functions, and it allows you to use functions written by someone else. So basically, the developers of the C++ language, they included with the language a number of libraries. One of them is, for instance, the IOStream library. So what is included in IOStream? Well, the types of functions that we typically require that is made available by IOStream are the cin, cout. Those are the functions that we typically need in there. One of the other libraries that we always need is the C standard library, cstdlib. Now, what is inside the C standard library? Well, these are things such as the exit function. We typically need the rand function that's typically in there. srand is also in there. What am I forgetting? I think these are the ones basically that normally we will find in the C standard. There's obviously quite a few more, but these are the typical functions that we normally use in our projects that's included in IOStream. So I'm just going to do this here as well. Cin and obviously cout is part of IOStream. Now, what is interesting is IOStream also makes use of the string data type. So automatically, well, normally string is also included when you do include IOStream. So that's quite a nifty or a nice thing that the C++ developers helped us with. The next thing that we require is when we generate random numbers, we normally have to use some kind of seed that we seed our random number generator for, and that makes use of the time function. Now, the time function is available in this library called ctime. So I'm just going to say here, time, boom, boom, that is the function that we're going to need. What else are we going to need? I normally also use, because I use a special container called the string stream container. And okay, that's just my phone telling me that I need to bring up the late viewing register. Late viewing register code for today is TBHS7113. Okay, so that's the late viewing register. So if you're viewing this recording at a late stage, please go and put this in our late viewing register so that we know that you are in fact attending these lectures, but retroactively. Thank you. Okay, let's get back. So what I wanted to mention is the sstream library. And this library is useful because we use the string stream containers, all the classes, and that is part of sstream. Now, one thing which you can also include, because you actually get marks for that, is to start using the asserts. So cassert is the library that allows us to use the assert function. Now, that is the basic libraries that we need. And just to help us, otherwise we may end up with some weird warnings and errors, is using namespace standard. And that just informs us that if we, for instance, have some kind of function here that returns a string as an example, that it will know that string is part of standard. Otherwise, you have to do this the whole time. Okay, let's talk a little bit about, again, what is a namespace. Let's just, again, save all of this. And let's just, again, compile. See if there's any errors or mistakes. Okay, I can't see any problems, which is great. So the question is, what is a namespace again? So what a namespace helps us, and I've mentioned this in some of the previous, obviously, lectures. A namespace is kind of like a surname of a function. So for instance, we have the cin and cout functions. So that's not the best place to use it. Let's go to main.cpp. So in main.cpp, I can, for instance, do this. Int num, whatever, cin, boom, boom, int num. Now this cin function itself actually has a surname. Think of cin as its name, and the surname for cin is std. No, it doesn't stand for sexual transmitted diseases. It actually stands for standard. So that is the standard namespace, meaning the cin function that belongs to that standard namespace. So this is kind of like people calling me Yaku, that's my name, that portion of it. De Toy, that's my surname. Okay, so this is the surname for cin. And the functions that we are declaring in this namespace can be referenced by our function name is, or namespace is sri space colon, and then whatever function name we've given it. So this is the function name, and this is the surname. Now, when we create this description on top that says using namespace, the compiler will try and associate a function to that specific surname first, before it might give an error. Otherwise, if you did not have using namespace there, you have to specifically describe the surname itself. Okay, so for now, let's pause. Let's see if there are any questions so far. Okay, there's a few. Okay, I've answered that. Thank you. Sir, is the library inclusion case sensitive? Yes. So Mr. Sabanda, Ms. Sabanda, any spelling in C++ is in fact case sensitive. That it goes for variables, namespaces, anything like that. Those are all case sensitive. The only things that are not case sensitive, I just want to think. I think it's the preprocessor arguments, for instance. No, those are also case sensitive. Yeah, no. So if you're ever in doubt in C++, case matters. Mr. or Mrs. Mambura, sir, just to confirm, in VPL, running the program is the same as submitting it, right? You're 100% right. In fact, saving it is actually the same way as submitting it, because every time you save it, it updates the file that's already inside the VPL. Okay, so that is basically the same as submitting it. You don't have to run it, just saving it. Okay, hashtag include libtrial is the same as hashtag include libtrial. Oh, I understand, Sabana. No, it's not. Plus .h. Although that is a good question. Probably on the VPL it will make a difference, because meaning the case of the file names itself. Because in Windows doesn't really see file names, or is not case sensitive with file names. But our VPL runs on top of a Linux implementation, so there it will definitely make a difference for the case. Mr. or Mrs. Khatla, would it not be redundant to include the IOStream library in both the header file and the main.cpp? Perhaps not. Let me explain to you some of the advantages and disadvantages of doing it both. So if we go here and we look at the library files included in our header file, because our header file is automatically included here, effectively I can remove it here. So you're 100% correct. It basically makes it redundant. It is not the best type of coding, however. It's not very clear, because a lot of developers actually like to see which libraries are required inside the implementation file itself. I personally feel that, you know what, for Computer Science 1A, this is a quick way to include the libraries that you want without having to copy and paste it or recreate it everywhere else. If you put it in your header file and you've got your header file defined in both the main.cpp and your implementation file, you know the libraries will be available in those files. So this is just a quick and dirty little trick that I use in this. It's probably not the most cleanest way of developing it or programming, but it's okay for Computer Science 1A. Let's look at another question. No, when you send, you evaluate. Okay, it's not C++. It's not C++ is case. Okay, that was answered. I think the C standard also. Oh, the system function. Yes, Mr. Savannah, you're 100% correct. The system function is also part of the C standard library. 100% right. Will you also include C time? I think I've included that now. Do computers at the venue have code blocks to make sure life is easy? Yes, Mr. or Mrs. Kalushi. It does have code blocks. We covered this yesterday as well. She's my Wi-Fi is bad. Okay, sorry. Sure, we could just add that standard C out at the top. So we could just add that standard C out at the top. Okay, okay, someone raised their hand and dropped it immediately. I'm not sure how you can just include it at the top. Okay, will they deduct marks if you include a library you do not use? No. So if write stdc in, it will also capture an input. Okay, so if I write standard C in, obviously yes. So I think Mr. or Mrs. Ndove asks, if you write any function with their namespace in front, then it actually will do anything. So let's see if I can explain that better. If I do this, let's say int num, boom, cin, int num, right, and std, colon, cin, int num. That and that is exactly the same. This one, the compiler figures out it's part of the std namespace. And this one, we specifically told the compiler it is in the standard namespace. Okay, so these two results are exactly the same. In fact, let's save and let's run it. We should actually be able to input something. Wait for, oh, there's a hashtag include libmodel.h. Let's see, there's a mistake here. Cin does not name, space standard does not name a type. Did I make a mistake here now? Oh, my goodness. Sorry about this. This was not the correct file. Oh. There you go, that's better. Okay, let's try again. That was a horrible mistake that I made. Okay, perfect. So I can now run. So 4 and 3, and then that's the end of the connection. Okay, so that is how it effectively functions. Right, so definitely you can copy and paste from code blocks here. I'm going to do the whole thing in this DPL just to show you that it can be done. But obviously, if you feel a lot more comfortable, programming it in code blocks will just save you a lot of time. Okay, so Sabanda, okay, why include a library that you won't use? Okay, so that was Mr. or Mrs. Kayo. Yes, it will. Okay, thank you. Right. Will the recording be uploaded before the end of the day? I'm having network problems. I've tried to normally do before the end of the day, but guys, I also have a life. So normally my last lecture ends at just after 6, and then, well, just before 7 actually. And then I've got another session starting at 7. So normally by that time I'm quite tired, and then I still have to download it, upload it to YouTube. Remember, you can always watch it immediately after this from Blackboard. It will be available on Blackboard immediately. Thank you very much. Will this code be uploaded to Eve, sir? I will have to see how I can do this, but I can definitely upload this code to Eve once it's done. At the moment, it's a little bit useless. So, yeah. Let's go on. Let's go back to my header file. What else do I normally like to do in the header file when we start the project. So normally I also like to start including things such as defining our type definitions, and I also like to start defining my const variables. So let's just talk a little bit about the type definitions. When we look at our problem, we already see that this thing will be some kind of two-dimensional array that I'm going to have to create. Now, type definitions help us to declare these aliases for our two-dimensional array. And I like to put this already in because when I know it's in there, I don't have to worry about it anymore. And in this example, I'm probably going to make use of a two-dimensional array that's going to store some integers, because each of these characters will have a specific value, and I'm going to try and keep track of the health of these characters in a different array as well. So I'm definitely going to use an array of integers in my solution. So let's create such a definition, a type definition. So here we go, type def, and I'm going to say int star, and I'm never comfortable with a nice alias for this. So let's make it type, and this is a 1D array. So I'm just going to say one-dimensional array, and I'm going to create another type definition, and this one is for a two-dimensional array. So it's also a type for a two-dimensional array. Okay, so that's my type definitions, and I can make use of this at a later stage. Now let's look at the consts. In my example, let's just go back so that we know what we're going to use. Remember, we've made these notes on the side saying that there's going to be a number of actors or agents in my two-dimensional array. One agent will be a susceptible agent, that is a person that can be infected, that models a person that can be infected, a recovered agent, and an infected agent. And the recovered agent, we saw here at the bottom, there was something special about recovered, and that was here. When an infected character recovers, they have a fixed chance of becoming immune. This chance is specified. So effectively, a recovered agent can also potentially become immune. So it's a special type of recovered agent. So I'm going to declare that as a separate agent, so that because it will help me a lot to figure out whether a normal recovered agent can, for instance, become infected again, and that kind of thing. For instance, they say here, a susceptible or a recovered character has a cumulative chance of becoming infected again. So I have to handle recovered and susceptible agents or characters separately from, let's say, for instance, an immune character. So let's create another one here called immune. Oh my goodness. Remember, that's why I put that little star there at the back, immune. So these are the agents that I'm going to require, and let's go and create some values for them inside my solution. Okay, there we go. So const int, and I'm going to say value of, let's say, nice words, susceptible, SUS, acceptable maybe, and let's give that a value of 1. Obviously, I haven't made a note here, but there should be some empty space as well. So I'm just going to make a note of that as well. Value, I'm just going to say empty space. I'm going to give that a value of 0, so that whenever we move our characters and we want to figure out if it can move into a location, we just see, hey, is there empty space there? Then we can move. Okay, next, int value susceptible, and that was recovered. Value and recovered, we have infected, and then there's an immune one. Immune. Okay, so that is defining some of my consts for my characters. Let's also define how I'm going to output them. So ch empty will be declared Let's make that a dot so we can actually see our grid. Let's say its acceptable character will be an S. I think that will help us remember when we see these little things moving around. And that means then that a character that is recovered will probably be an R. Why not? And a character that is infected. Shame. What shall we call it? Let's make it a star, just to be nasty. So that is an infected person and an immune character. Let's make that an I. That is immune. Okay, so that's going to be my output values. Output. And that's my consts. Okay. What I also like to do is my exit values. But before I get to that, let's see if there's any questions. Our time is nearly up. Let's quickly see. Okay, what does an alias? Okay, where must we use the type definitions? Okay, type definitions are used for aliases. We covered this when we talked about two-dimensional arrays. The advantage of using a type definition, so let me see if I can explain what is a type definition and how we use that, is it makes it a lot simpler for us to create and talk about our two-dimensional and one-dimensional arrays. For instance, I can create a variable here, and the variable can now be a type, can be a type two-dimensional array, so let's just do that, and that can be an array world. And you can easily, by just looking at the words, figure out, oh, array world is a two-dimensional array. Where if I did that, it's not clear that that is actually a two-dimensional array, because that actually technically means it is a pointer to a bunch of integers. That's actually what it means. So it is, I like to use this. It's also a lot easier that if we pass these variables in functions, or when functions return this, it's a lot simpler to refer to this alias type 2 array instead of that. So this is, what does a type def do? It creates an alias. So when we do the test, must we include comments like you're doing, or is that just to help us? There are marks given for comments. So yes, comments are always a good idea. I think you should, because they have marks. Yes, thank you. Okay, Mr. Lebaka, there's something about alias, I believe. Type def is just giving a name. Okay, thank you very much. Yes, you've explained type def perfectly. Thank you very much. Okay, so in the way we don't need to keep creating pointers. Well, you actually do create pointers, but it's a lot simpler just to refer to it. Okay, guys, unfortunately our time is nearly up. I am not going to continue with the lecture. I'm going to pause it here, and then what's going to happen in tomorrow's lecture, we'll finish the exit values, and then we're going to start the next phase. And my next phase is normally where I look at the command line arguments. Now, that is going to be a little bit tricky for VPL, because we don't yet know how we're going to handle command line arguments. So Prof. Coulter is working on that, but it is still required that I have to demonstrate how we're going to use command line arguments. Even in here, it won't work very well in VPL, so but I'm going to cover this anyway. Okay, guys, I'm going to stop sharing now. Thank you very much for those attending. I'm going to have my tutorial that will start. I have my time right. No, the tutorial only starts at 5, so we actually have time. Sorry, I'm totally incorrect. We actually have time. I can actually finish this exit value. So let's do that. Another exit values, which you will definitely get marks for, is if you start declaring some of these exit values, and always declare success. Believe it or not, this is kind of like the standard thing that we look at when we mark. So success, and then immediately return a success. Boom, marks achieved. Right. There's a question. Can I stop? Thank you very much. I'm not sharing my screen. Let's just share the screen again. Oh man, I'll get there one day when I'm big and. Yes, thank you, Mr. Ndove. We have 10 more minutes. You are correct. Sharing the screen. There we go. So what I mentioned was going to include these as well. So success has been added. And I immediately just went to main and I added success here. And as always, save and run just to make sure I did not make any syntax errors anywhere. Okay, so far so good. No syntax errors. Excellent. Let's continue. That's my little thing that tells me I have to nearly go and do the tutorial. Right, let's get a few other exit values as well. And the reason why I always do this in the beginning is because it helps me remember to do these things. Now, I know, again, by experience in doing these semester tests and exams and preparation for them, that there's always a place where we're going to have to handle command line arguments. And the user might not provide the correct number of command line arguments. So error argc will means argument count will be incorrect. Okay, what else is there? Const int, let's say error. There's a conversion error, perhaps. That is where we could not successfully convert from the command line into an integer. So maybe the user didn't type in numbers, they typed in gobbledygooks like SD, blah, 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 whatever, string characters, normal string characters like alphabet characters. Then obviously the trying to convert an alphabet character into a number will fail. And I always, because we do handle error and we give marks for error, let's remind myself to put in a range. Error as well. And I'll probably forget about something now, but these are some of the errors that I need. Okay, so let's just quickly recap what I did today. So hopefully you've learned that the next phase in working in something like a semester test or the exam is to set up your environment, meaning create all the files that you need. You start obviously with main.cpp. Then you start and you create the header file, and then you create the implementation file. Once you've created the header file, if you're using the VPL, remember to create the guard conditions at the top and the bottom. Then you include the header file as a library component, so your prototypes will automatically include it in the implementation as well as in your main file. And then I declare my namespace. That's normally the next thing that I do. I took my namespace, which in this case is SRI space. I declared it in both the header and the implementation files, and I said I'm going to use this in my main file. Once I then did that, I started including all the various libraries that I potentially might need in my project. So I started with IOStream, standard libraries, ctime, sstream, cassert. And because I know a lot of those functions belong to the standard namespace, I would immediately have my declaration of using namespace standard here. Otherwise, I have to continuously have the std : in front of the function name. And I declare the namespace in my implementation, and I am using the namespace in my main file. Once I do that, I actually then go into setting up some of my variables. And these variables are consts, because if you don't put the word const in front, then you're in very dangerous territory, because what you're then doing is you're creating what they call global variables. And that's where if you don't handle it correctly, the C++ linker starts getting really angry when you don't use it correctly. So the only place where variables cannot belong to a function is if you declare them as constants, okay, which is the case here. Can you see they're not belonging to part of a function? They're just part of the normal namespace, not part of a function. Okay, that's it. That's what I wanted to cover today. I'm not going to continue. Tomorrow, we will go further and we will focus on this initialization portion, and we will only focus on the command line. Why? Because there's a specific mark component. If you look, for instance, at the actual mark sheet, you'll see that there's command line argument. You get 5 marks if you do the command line argument successfully. So we're going to focus on C6 tomorrow, and then we will continue with the rest of the functions that we're going to start needing. Okay, that's it. That's what I wanted to talk about today. Let's see if there's any more questions before we wrap this up. Do we start with the design, or the design can come after? Let me just see if there's any other. Share your screen. Sir, at APKD Labs, I cannot run the code and I do not know why. Okay, unfortunately, that is very vague. I'm not sure exactly why you cannot. You have to try and maybe help us a little bit more. Why did you use negative integers? There are at the errors. Yes, so normally I'd like to use a standard where negative numbers are errors, positive numbers are exit values where there's not errors. Okay. Different types of programs use different types of standards. Certain programs have positive numbers even as errors. I typically just standardized on negative numbers. But I mean, you can use positive numbers if you like to. Do we start with the design, or the design can after the program? That is up to you. Remember, the design is 10 out of 100 marks. That means you can get potentially some marks for it, but don't waste too much time on it. Don't spend more than 18 minutes on the design. Okay, otherwise it's not very good using your time. Command line arguments means that because it's not line, we are on PowerShell. I'm not sure I understand what that means. Okay, command line arguments, I will discuss that tomorrow, but that's typically where you add certain arguments to the program when you run it. Okay, whether in PowerShell or CMD, that's immaterial. Both PowerShell and CMD uses command line arguments, but VPL is a little bit of a different monster. So I'm not sure if we can get it right in VPL. Command line arguments have been covered. Okay, so what is decomposition? I'm not sure. You have to give me a little bit more context, Mr. Cello. We'll maybe discuss this on Discord. Just part of the style, nothing special. Okay, it's in our mark sheet. So lib.h, we would get errors if we don't have const variable. So Mr. Sabanda, if you don't create your variables as const in your header file, then there's a big chance that you will get errors during the compilation and the linking. Okay, depending on how you use it, it's not guaranteed, but please never, ever, ever create what they call global variables. That is really horrible. So we will do C6 tomorrow in the tutorial and the class. Well, the tutorials is based on trying to get one big project in at the time. So the tutorials will not cover the same problem. It's not the same semester test or exam that we're looking at. It's a different one. So we will actually try and do the whole one today, depending on how fast and how many questions I get. What does today's TUT compose of? Let's wait for the TUT. I'm talking about task decomposition, task decomposition means you break up your problem into smaller problems. Okay, and that is functions. That is what task decomposition means. Does our type definition int array type have to be inside the namespace? You don't have to, but it immediately helps you to give it some kind of identity. Oh, thank you, sure. I have seen multiple definitions of variables, and that might be because of const variables. Will we get our marks immediately after evaluating for your semester test? No. Semester tests are marked by hand. So no. Okay, guys, that's it then. Thank you very much. I will see those that will attend the tutorial a little bit later. Otherwise, watch the tutorial then at a later stage.